Okay guys, we're going to start with some regular polygon area. In case you haven't heard this term before, regular just means equilateral and equiangular. So using this formula of area equals AP divided by 2, we can find the area of any regular polygon no matter the number of sides. Just a quick run through of some vocab. We have radius, apothem, side, perimeter, area, and then we have our area formula. So when we look at our regular polygon, if I start from the middle and work straight down to the side, where that side is perpendicular to the center, this is what we call our apothem, and I label it with a little a. And we have this figure inscribed inside a circle. And if we were to draw in a circle's radius, it would also intersect the vertex of our polygon. Of course, perimeter is the same as the distance all the way around. And our side length will be this entire side here. Okay, so a few things that we're going to have to pay attention to is this central angle right here. So if you can imagine, I'm going to change colors here. If you can imagine that we go through and we make these triangles all the way around, we are going to have 5 triangles, and then if we split them, we're going to have 10. And with those 10 triangles, every single one of these central angles will be congruent. So if I take those away, the way that I can get this central angle here is to do my 360 degrees and divide it by 2 times n, where n is our number of sides. And you'll hear me refer to this as your central angle. So our area formula is, you'll see me write a lot of times 1/2 apothem times perimeter. I tend to use a capital P for perimeter just because that's what we've always done with all of our formulas. We use the big B for area of the base, which we'll actually use in Unit 7, and we can use capital P for the area, capital P for the perimeter of this whole thing. So we've got 3 special ones here. If I take my square and I split it straight down the middle, here is my radius, here is my apothem, and a couple of things happen whenever I drop that apothem down with any of these regular polygons. It splits my side perfectly in half. So if you can envision, this angle here is going to be 360 divided by 2 times my number of sides, which is 4. And whenever we work that out, if I do 360 divided by 8, this ends up being a 45-degree angle. Well, back in the Unit 5, if you think back to our special right triangles, then whenever I split this square, I have a 45, 90 triangle. So just a quick refresher here, if I've got a 45, 90 triangle, these two are going to be the same. And remember that we have our A and A and A root 2. This is that same triangle that you have inside your square. If we move on to an equilateral triangle, I'm going to start in the middle and drop my apothem straight down so it splits my side in half. I'm going to draw in my radius. And if I do 360 divided by 2 times 3, which is 6, then up here at the top I end up with a 60-degree angle, which means that I have a 30-degree down here at the bottom. Again, quick reminder from our Unit 5. If I have got a 30, 60, 90 triangle, then I have my short side is A, my long side is a root 3, and my hypotenuse is 2a. And the last set here that we have, if I drop my apothem down in this hexagon, then I have got my radius and my apothem, and down here is my side length. So again, we have that 30, 60, 90 triangle, except now it's flipped. Now my A value, or if you want to think of it as X, since we're using these in terms of apothem, this would be X. My long leg would be X root 3, and this over here would be my 2A. That central angle up there at the top ends up being 360 divided by 12, so my 30-degree angle lies in the middle this time. We're going to use this information to not only find our perimeter, but also find our apothem so that we can then find the area of these polygons. Our squares, equilateral triangles, and hexagons will all contain these special right triangles. And if they contain those special right triangles, we want to use AP over 2 to find the area so that then we can have our answer in exact form. So here we have an apothem. This little a is not the area, it's the apothem of 10 meters. I'm going to go ahead and draw that in. I know that you guys know how to find the area of a square, but I just want to go ahead and show you that this 1/2 AP works. So I'm going to have 10 here and 10 here, since I have my 45, 45, 90 triangle, and 10 square root 2 as my radius. So if my half side is 10, then my entire side is 20. And if my entire side is 20, then my perimeter will be 20 times 4, 80 meters. And for my area, I know that you can do your 20 times 20 and get 400. But if I do 1/2 apothem times perimeter, I end up with 1/2. My apothem is 10. My perimeter is 80. And so that becomes 1/2 of 800, which then gets me that same answer of 400 for my area. Over here on number 2, I'm going to go ahead and draw in my triangle as needed. So here it may not be perfect, but it'll be close enough. It tells me that my radius is 6 square roots of 2. Let's see, 6 square root 2. It doesn't have units, so I'm just going to put a U. If my triangle has a 45, 45, 90 setup, then if I remove the root 2, my apothem has a length of 6, which means that this is 6 and my side length is 12. So 12 times 4 gives me a perimeter of 48 units. Once again, we can just do 12 times 12 to give us that 144 units squared, or we can plug it into 1/2 AP, 1/2 of my apothem 6 times the perimeter of 48. So this is 3 times 48, which then gives us that 144 for our area. Let's take a look at some triangles here. I have my setup here. Remember that in our triangle, this measure up here is 60 degrees. So this is 30, and there's our 90. Our side is split in half. It tells us that our radius is 8. And always work back to the short side. Remember that we have our setup of 2A, 2a, and a square roots 3. So looking back at that, my apothem is going to have a value of 4, and this piece of the side down here is going to be 4 square root 3, which means that if I double that, my side length is 8 square root 3. So let's go ahead and plug all this in. 8 meters for my radius. My apothem is 4 meters. My side length is 8 square root 3. And I have 3 of those. So remember that this is like 8x plus 8x plus 8x. So I'm going to have a perimeter of 24 square root 3 meters. And here is where we don't want to use base times height divided by 2. We want to use 1/2 AP. So I'm going to go ahead and set this up. 1/2, my apothem is 4, and my perimeter is 24 square root 3. I'm going to go ahead and take half of that. So 2 times 24 square root 3 gives me 48 square root 3. Let's see what our units are, meters squared. And on the next one, we're given the perimeter. So if I divide 24 by 3, each of these sides has a length of 8. Go ahead and draw in my triangle here. Got my 60-degree angle at the top, 30 in the corner, and my 90, my 8 is split in half. Now, when we look at this piece, here is our A, 2a, and a square root 3. So whenever we work this one here on the right hand side, I want to take this apart. My length at the bottom is 4, so my perimeter, it already gave us, is 24 meters. My side length is 8 meters. And now let's work to find our apothem and our radius. So if I want to take 4 and work back to the short side, I'm going to have to divide by that root 3. We've got to rationalize the denominator. So I end up with 4 square roots of 3 over 3. And that is it. So 4 square root 3 over 3. And then I need to double that. Whenever I double that, only the 4 gets multiplied by 2 because I'm multiplying it by 2 over 1. So my radius would then be 8 square roots of 3 over 3 meters. All right, so whenever I plug all of this into 1/2 apothem times perimeter, I'm going to have 1/2 times my apothem, 4 square roots 3 over 3, times my perimeter, and I'm going to go ahead and list this as 24 over 1. I'm going to do some things to cross simplify here. So the 2 will bring the 4 down to a 2. And this 3 will simplify with the 24 to give me an 8. So now I just have a bunch of 1s in the denominator. And now let's multiply our outside numbers on the top. 1 times 2 times 8 is 16. And then we bring in the root 3. Okay, last shape that we're going to take care of today is our hexagon. So I'm going to go ahead and split this up. If I split my side in half, here's my 90-degree angle. This figure has 6 sides, so if I do 360 divided by 2 times 6, which is 12, that gives me a 30-degree angle up here at the top, and will give me a 60 down here at the bottom. tells me that my side has a length of 10 meters. So if I take half of that, this will be 5. Now, here's my side length of 10. If I work with my special right triangle, sometimes it's easier to draw them out here to the side so you don't get your sides confused. This side is 5. Here is my 60. In the wrong spot. Here's my 60 and my 30. So this is my short side. Here is my long leg and the hypotenuse. So if 5 is my short leg, then my long leg has a value of 5 square root 3, which in this case is my apothem, 5 square root 3. And if I go back to the short side, 2 times that is my hypotenuse. So my hypotenuse has a value of 10, which is also my radius. All right, my apothem is 5 square root 3. My perimeter will be 6 times 10, so 60 meters the entire way around. And 1/2 times apothem times perimeter will give me 1/2 times 5 square root 3 times 60. I'm going to go ahead and do the half and the 60. So 30 times 5 square root 3. It does not matter which one of those you take a half of. Just make sure that you only take a half of one of them, not both. So I'm going to have 150 square root 3 meters squared. And last one for today, if I have a radius of 12, this side is split in half. That is my hypotenuse. So if I work backwards, my hypotenuse is 12. I'm going to divide by 2 to get this short leg. And from the short leg to the long leg, I'm going to multiply by the square root of 3. So my radius is 12 meters. My apothem is 6 square root 3 meters. My side length will be 6 times 2, which is 12. And my perimeter will be that 12 times 6, which is 72 meters. And for my area, 1/2 AP, 1/2 my apothem, 6 root 3, times the perimeter of 72. And if I do 3 times 72, that will give me 216 square root 3 meters squared. Please try to stay organized. Keep in mind that you don't have to draw out the entire figure. You don't have to draw out a hexagon. Really, all you need to draw out is this triangle here. So if you have this triangle and you know that you're dealing with a hexagon, you can say, okay, this is 360 divided by 12, so I've got my 30 here and my 60 here, and work from there. Remember that you need your apothem and your perimeter. You don't need your radius unless we are asking you for it, but keep track of your pieces, because as you plug them into the formulas, it's just going to be even more imperative that you keep track of what you're doing whenever we add that third dimension in the next unit for volume.